We're here at the Kennedy Space Center Visitor Complex to learn about how NASA is exploring Mars with the help of space companies like Honeywell. But how is this exploration helping to prepare us for sending humans to the Red Planet? Let's find out in this episode of How to Build a Spaceship. NASA has been sending robotic missions to Mars for over 50 years. Each of these missions has built upon the missions sent before them to help fill in the pieces to the puzzle and answer the question of whether or not Mars has ever harbored life. Honeywell has been involved in this heritage, contributing microelectronics for the rovers and components involved in the entry, descent, and landing process. And now the next big chapter is beginning, sending humans to Mars aboard the Orion spacecraft.
How is designing a cockpit for a spacecraft different from designing a cockpit for an aircraft?
We actually started with the 787 and 727 displays, but we have a way harsher environment. We have to survive in a vacuum, we have to handle the vibration of a liftoff, we have to handle the harsh radiation environment out in deep space.
Why are there so many physical knobs and switches when you're inside a spacecraft? Shouldn't it be something more futuristic by now, like touchscreens that we have on our cell phones?
Astronauts like the feel of having knobs and switches on the console because they wear gloves sometimes. They're also operating sometimes with zero gravity, so if there's something floating around the cockpit and it happens to slide into the touchscreen display, it can actually cause parachutes to deploy, and we don't want that.
Good points. Are there any other factors that you have to take into account when you're designing human-rated vehicles for space?
When the vehicle comes back to Earth, it lands in the water, and there are times when you need to get oxygen in there fast, so there's a snorkel fan that opens up and it can dump salt water all over the console. We have to be waterproof too. We have to survive almost any imaginable environment that you can think of. I'm Lance Plummer, and I'm a proud space nerd.
In order to get humans to Mars aboard Orion, we're going to need a lot of thrust. To do that, Orion will be launched toward Mars aboard the massive Space Launch System rocket, or SLS.
What is a liquid rocket?
A liquid rocket is a term that's used to differentiate it from a solid rocket engine. A solid rocket engine is really like a firecracker, whereas with a liquid rocket engine, you can actually control it by the regulation of the fuel that's burned inside the combustion chamber.
Does the controller actually guide the rocket?
What the controller does, it controls the valves and pumps to make sure that the right mixed ratio of liquid hydrogen is supplied to the combustion chamber. The engine controller, or the brain, actually has to keep track of the thrust and direction of each one of the engines. And it has to do this in tandem just to make sure that they're working together.
Is there actually a human that's piloting the rocket?
What happens is the flight computer actually has a trajectory that's pre-programmed into it to make sure that it goes on its proper flight path. Honeywell provides the guidance sensors that send the position and velocity information back up to the flight computer. All of this guidance and flight path adjustments, they happen so fast that no human could actually react that fast. So the main flight computers actually pilot the rocket.
Both SLS and Orion will be thoroughly tested for both performance and safety over the next few years as NASA works toward the goal of sending humans to Mars.
I'm Reggie Sherman, and I'm a proud space nerd.
Orion and SLS will enable humans to travel further into space than ever before, allowing us to reach beyond the moon and explore the outermost parts of our solar system. Maybe that means I'll be able to take a cruise through the rings of Saturn after I retire on Mars.